Okay, what I wanted us to do now is I'm going to walk you through this handout about how to draw Lewis structures. Let's take a look. The handout in question is this guy right here. Let me walk you through this in case you are not able to join us in class. Or even if you are, this is a good introductory video. Let's say we want to draw the Lewis structure for CH2O. Well, the way I'm going to do that is step one. I want to draw the atomic Lewis structures for each atom. So carbon would have 4 valence electrons, hydrogen would have 1, and oxygen would have 5. And when I do this, I want to draw 1 electron on each side as I go around. So for example, oxygen will have 1, 2, 3, 4, and then I'm going to start pairing them up, 5, 6. That's how I draw them, 1 on each side. And I go around and pair them up. And the atom with the largest number of unpaired electrons, which is just single electrons, that's the central atom. And in this case, that is carbon. The next thing I want to do is add up the total number of valence electrons. So for CH2O, that means I have 1 C, 2 H's, 1 O. And I see I have 4 plus 1 plus 1 plus 6 when I add up all of the valence electrons. So that means in total, I have 12 valence electrons, and that's the number of electrons that I have available to use. So when I add 4 plus 1 plus 1 plus 6, I know I have 12 total to use. The next thing I want to do is draw my central atom, and I want to surround it with the other atoms. That's what I see here. The next thing I do is I connect the central atom to each of the outer atoms with a single bond. And remember, each bond represents 2 electrons. So what that means is when I've drawn these 3 bonds, and I'll draw them here too, that means I've used 6 electrons. I started out with 12, I used 6, I have 6 left to use that I must place. And I place them around the one of the I basically place them around the outside atoms. In this case, I'm going to put them around O because hydrogen can't handle anymore. Hydrogen just needs 2 electrons to form a full outer shell. So once you draw a single bond to hydrogen, you are always done with hydrogen in that case. So I'm going to draw those 6 electrons around oxygen. And I've used them all. So I have none left to use. I have used all 12 electrons. Because remember, each of these bonds represents 1. In fact, I'm going to draw that here. Each of these bonds represents 2 electrons. So I've used 12 in all. But notice I need to count for one thing. I need to count the electrons around the central atom. If it does not have 8, let's count the electrons around the central atom. Carbon has 1, 2, 3 valence electrons, and then 3 shared with it. So for a total of 4, 5, and 6, it has 6 total valence electrons. I'm sorry, 6 electrons in total. It has 3 valence electrons and 6 electrons in total in this picture. And that's not good. We want it to have 8. So if it does not have 8, I need to convert 2 electrons from here into a double bond. And so if I were to go up here, that means I would erase 2 electrons here and draw a double bond to share 2 electrons. Notice that when I do this, 2 things. So here, carbon has 1, 2, 3, 4 valence electrons around it, and it has 8 in total. 5, 6, 7, 8. Hydrogen each has 1 valence electrons. That's right, and it has 2 total. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons and 8 total. So each atom has the right number of valence electrons and a full outer shell. So that means it is a correct drawing. Let's do this one together, NH3. Let's do this one together. Step 1, remember, is I need to draw the Lewis structure for each atom. So here's N, 1, 2, 3, 4, 5 valence electrons it has. H has 1. Now I know N is going to be the central atom because it has 3 unpaired valence electrons. So I have N, 1, 2, 3, 4, 5, and I'm going to surround it with 3 hydrogens. The next step is to, well, actually, I think I skipped ahead. Step 2 was to count my number of valence electrons. So, in fact, let me just erase this. Step 2 is to count the number of valence electrons that I have. N has 5. Oops. Step 2 is to count the number of valence electrons that I have. N has 5, and I have H, which has 1, and I have 3 of these. So 5 plus 1 plus 1 plus 1 gives me 8 valence electrons that I have to use. Now I'm going to draw my N, and I'm going to draw my 3 H's around because my N's in the center, and I'm going to connect them with single bonds. I have used 1, 2, 3, 4, 5, 6 electrons. I have 2 left to use. I cannot put them on the H because the H is full. So my step 4 is to put my 2 electrons over N. My step 5 is to count the number of electrons around the central atom. I have 1, 2, 3, 4, 5 electrons for nitrogen. And if I add up the ones that are being shared, I have 6, 7, 8 around nitrogen. It has 8, and so we are good. We don't need any double bonds or triple bonds. Notice also that nitrogen has 1, 2, 3, 4, 5 valence electrons, which is what we expect. We expect nitrogen to have 5 valence electrons. Each hydrogen has 1 valence electron, and that's what we expect. Let's do one more. Let's do carbon. The first step is to draw the Lewis structure of each atom. That's carbon. Let's draw oxygen. Oxygen is 1, 2, 3, 4, 5, 6 valence electrons. This guy has 4 unpaired electrons, so we know carbon is going to go in the center. Now, before I do that, I need to add up my valence electrons. I know carbon has 4. I know oxygen has 6. And I have 2 oxygens because it's CO2. So let's add up. That's 4 plus 6 plus 6. I have 16 valence electrons that I can use. My step 3 is I draw my carbon in the center, my oxygens on the side, and I draw one line to each. I have used 4 electrons. 16 minus 4 is I know I have 12 left. Let's place them around the outer edge. I should say on the outer atoms. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've used all 16 electrons. Now my step 4 is to count the number of electrons around carbon. It has 2 valence electrons and 2 that are being shared from oxygen for a total of 4. But how many does carbon need around it in order for it to be happy? It needs 8. So I'm going to move some of these outer electrons to double bonds. Now carbon has 6 electrons around it. Let's do that again. If I do it over here, now carbon has 8 electrons around it. Let me show that to you. Now, carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons, and that makes it happy. It's got 4 valence electrons and then 2 being shared from each oxygen. So now it has 8 total of electrons. So that is the Lewis structure for oxygen. And I'm going to redraw it, and it's going to look just like this. It has 2 double bonds with each oxygen. In class, we're going to try these on the next page together. You can try answering these questions on your own, and then try answering these questions. We will go over this in class.